Hello students, welcome back to the very important module, that is solution of a triangle using cosine rule. What is a cosine rule? A square is equal to b square plus c square minus 2bc cos e. Second formula is b square is equal to c square plus a square minus 2ca cos b. The third is c square is equal to a square plus b square minus 2ab cos c. So all these are the three formulas for the various angles of a triangle. Now make sure about some remarks. First one is, if angle B is 90 degree, then cos B has to be 0. And by using the triangle ABC as a right angle triangle, if you see, if cos B is 0, in equation number 2, if cos B becomes 0, 2ca, the whole term becomes 0. So the equation gets shrink to b square is equal to c square plus a square. Also, the cosine formula can be written as cos A is equal to b square plus c square minus a square upon 2bc. Cos B is written as c square plus a square minus b square upon 2ca. Cos C is written as a square plus b square minus c square upon 2ab. In other words, the angle of which you have the cosine is subtracted on the right hand side. So moving ahead with the problems. In triangle ABC, you need to prove that a cube into sine of b minus c plus b cube into sine of c minus a plus c cube into sine of a minus b should be equal to 0. Let's start with the solution. In this case, we are considering only the first part, that is a cube sine of b minus c. We know that a cube into sine of b minus c can be expanded in the form of sine a minus b, which is sine a cos b minus cos a sine b. So here it would be sine b cos c minus cos b sine c. By sine rule, we know that a cube remains as it is. Sine b can be represented as kb into cos c minus cos b into sine c would be kc. Now, if you have observed this equation, k is constant in the complete equation, so it can be kept out as a common, and out of that a cube, a square is kept and a is inserted in the bracket. As a result, you get ka square into ab cos c minus ac cos b. Now, by applying cosine rule, ka square into ab cos c becomes a square plus b square minus c square upon 2ab minus of ac into cos b becomes a square plus c square minus b square upon 2ac. In this case, you observe that a square k remains constant, but ab gets cancelled, also ac gets cancelled. So equation is a square plus b square minus c square upon 2 minus of a square plus c square minus b square upon 2. When you take the common LCM, it would be a square k upon 2 into a square plus b square minus c square minus a square minus c square plus b square. And in this case, a square, it gets cancelled. So what the equation is, a square k upon 2 into 2b square minus 2c square. Even from this, if you take 2 common, the equation would be ka square upon 2 into 2 into b square minus c square. So when 2 and 2 gets cancelled, equation would be ka square into b square minus c square. Similarly, we can also prove that for b cube into sine of c minus a, that is nothing but kb square into c square minus a square, and c cube into sine of a minus b would be equal to kc square into a square minus b square. So now considering left hand side, that is a cube sine of b minus c plus b cube sine of c minus a plus c cube sine of a minus b would be equal to what? We know the a cube sine of b minus a is given by ka square b square minus c square plus the b cube term is given by kb square into c square minus a square followed by kc square into a square minus b square. So in all these terms only k is remaining constant. So in the brackets we have a square b square minus a square c square plus b square c square minus a square b square plus c square a square minus b square c square. Now if you observe carefully, a square b square is getting cancelled, followed by that a square c square gets cancelled, and last but not the least also b square c square gets cancelled. So what remains is k into 0, and hence answer is 0, and which is your requirement for the answer, which is my right hand side. Students, mark this problem very important. Thank you.